In this question, we're told that Eric is saving to buy a new computer, and it gives us some information about how much money he's putting aside, and we have to figure out which of these equations represents the relationship between the amount of money saved and the number of weeks that he's spent saving. So when we look at the equations, we've got savings, S, versus the number of weeks. So that if we look at a graph, that would be like so. We'd have S on the vertical axis and N on the horizontal axis. So if we were to put a table of values together, we'd have N on the left-hand side and then S on the right-hand side. So let's take a look. It says that Eric starts with some money. Therefore, after no week savings, he's going to have a little bit of money there. We're not sure what that is, but we know he's going to have some money to start. We're also told that he adds a constant amount each week. That means it's going to be a constant rate of change, not be a linear relationship. Okay, so after 1 week, he'd have some money. After 2 weeks, well, they tell us that he has $140, so we can put that in there. We know that one. After 3 weeks, he'll have something. And after 4 weeks, when we look at it here again, we see that he has $180, so we can put that information in there. Now, since we're told that it's linear, we know that the amount of money he'll have is equal to initial value plus constant rate of change. So if we can figure out these two pieces, we'll have our equation. So the rate of change would be the change in the amount of savings divided by the change in the number of weeks. So we go to our table of values and we pick the points that have values for both N and S. So we can look at the change from 2 to 4 weeks versus the savings from 2 to 4 weeks. So from week 2 to week 4, the savings increased by $40. So we'll put that there. And from week 2 to week 4, the number of weeks increased by 2. So we'll put that there. So 40 divided by 2 is 20. That means Eric's savings increases by $20 per week on a consistent basis. So we can replace the rate of change here with $20 per week. So that means 20 times N. Now we have to find the initial value. Well, if the savings are increasing by $20 a week, we know that, for example, in week 3, he would have $160. That way we can see that between 140 and 1 week he's going to go up by $20, and then in another week he goes up by $20 again. Using that same logic, we'll know that after 1 week Eric would have $120, and therefore at the start he's going to have $100. So let's just confirm. He's going up by $20 each week, so 100 plus 20 is 120, plus 20, plus 20, plus 20. It fits. So we know that the initial value, or the amount that Eric started with, is $100. Now what we could do is we could graph this as well if we wanted to. So we could say that, there's 2 and 4 for the number of weeks, and we've got $100, $200 perhaps. Okay, there's a 0. So initial value of $100, that means we could take the point right there, $100 to start. Then after 2 weeks he's got $140, which is about there. After 4 weeks he's got $180, which is just below the 200, and therefore we've got our linear relationship. Okay, another thing to note here is that this equation could also be written this way. S, you could put the rate of change first, so this could also be written as 20n plus 100. Doesn't change the value at all. So here's our linear relationship, and if we look down our list of options, we can see that A is the right answer. And there you go.